Hello dear learners, welcome back to my YouTube channel. I hope you have watched the previous videos on the sign convention, mirror formula and magnification, and I hope you are ready for solving the numericals. So in this video we will learn to solve numericals. So most of the students, they find numericals difficult. Actually numericals, it needs a little bit of understanding of the question and the concepts. So whatever concepts I have taught, please, if you have not watched that video, please go through that videos first and then you can come back for solving the numericals. So do watch the video completely. I hope this will be helpful for you in solving the numericals. Now, when students solve numericals, they think that they are not getting marks. So I will teach you the method and I'll tell you the steps where you will get the marks. Alright, so do watch the video completely and do share and subscribe my channel for further informations. So here I have taken one question. So the question says, a 5 centimeter tall object is placed at a distance of 30 centimeter from a convex mirror of focal length 15 centimeter. Find the position, size and nature of the image formed. So do read the question twice, thrice and try to analyze the question. Try to get the information that is there in the question, right? So first of all, you start with what type of mirror are they talking about. So in the question, you will see that they are talking about convex mirror. So underline this here. So we are talking about the convex mirror, or you can write, so we are having, or we have a convex mirror. For this you will not get the marks, but you will know what sign convention you have to use here. Then read the question again. So it says, so the value is given here, 5 centimeter and tall object. So 5 centimeter tall object, this means what? So this is nothing. So here you can write given. So for given also you will get some marks, half marks will be there. So given. So the first thing you can see here is 5 centimeter tall object. So that is nothing but height of the object and it is 5 centimeter. So this is the first thing or first information that we get, 5 centimeter tall object. Then it says placed at a distance of 30 centimeter. So placed at a distance of 30 centimeter. This means what? We know that we keep an object in front of the mirror and we are talking about 5 centimeter tall object and it is placed 30 centimeter from the mirror, right? So this is nothing but our object distance. So object distance will be 30 centimeter here. Then the next information is here, 15 centimeter. So what is this 15 centimeter? You can see of focal length. So that means 15 centimeter is nothing but it is the focal length of this mirror. So these are the three things that we get from the question. 5 centimeter tall object placed at a 30 centimeter distance having focal length of 15 centimeter. Now what are the things that you have to find? So you can see, find the position. Here position means the position of the image. Where will be the image formed? Or you can say image distance. So the things that you have to find out is, first you have to find out the image distance. Second, you have to find the size of the image. That means you have to find HI, height of the image has to be found out. Then the last one is the nature of the image. What will be the nature of the image that is formed? So these are the given things and these are the things that we have to find out. But before we use the formula, we need to use the sign convention. That's why sign convention is important. Otherwise, you will not get the correct answer. So here you can see we are using a convex mirror. Now height of the object, for convex or concave, height of the object will always be positive because we are keeping it always above the principal axis. So height of the object will be positive. Now the second thing is the object distance. Now object distance for both concave and convex. Since we are keeping the object in front of the mirror, we have to go to the left of the pole. So the sign convention for object distance will be negative. So U is negative. And the focal length, here we are talking about convex mirror. Focal length for convex mirror will be positive because focus is behind the pole. And the symbol that we use for focus, students make mistake. Capital F represents focus and small letter f represents focal length. So kindly use the correct symbol. So focal length of a convex mirror, the sign convention will be positive here. If you have not checked the video on sign convention, please do go through the video first and then you will understand why we are using these signs here. Alright, so we have this information. Now the first thing that we have to find out is the position of the image, or we can say image distance. So we have to find out image distance. We have given object distance and focal length. So from there only we can clearly understand which formula can be used here. We can use the mirror formula. So you can use an equation only if one of the variable is unknown. If two variables are unknown, then we cannot use that equation. So in mirror formula, we have u, v and f. So u and f is already given. You have to find v. So here you can write down using mirror formula. We have 1 by f is equals to 1 by u plus 1 by v. Now don't put the value directly here. So what we need to find is v. So take u to the other side. So this becomes 1 by f minus plus, when you bring it to the left hand side, it becomes minus. So 1 by u is equals to 1 divided by v. If you put the value here only, then you may get confused. So whatever term you have to find out, keep it single and take rest of the terms on the other side. So we get 1 by v is equals to 1 by f minus 1 by u. Remember 1 by u, we are taking it to the left hand side, plus becomes minus u. Now you can use the value with the correct sign. So here focal length is plus 15, so plus 15 is here. Then we have minus, object distance is minus 30. So you can write minus 30 here is equals to 1 by v. So you are getting marks for every step. Alright. So given with the sign convention, if you write it correctly, what are the things that you have to find out? You will get some marks here. Then write the formula, correct formula, and do the calculation. There will be some marks. So here we are doing the calculation for v. So here you can see, you have to simplify the equation. This minus and this minus becomes plus here. So 1 divided by 30 is equals to 1 divided by v. Now here you have to take the LCM. Now some of the students I have seen, they have problem with basic mathematical skills. So if you don't know how to find the LCM, then you have to learn that, because if you cannot find the LCM, then you cannot solve this. So do find out the LCM, or do learn how to find out the LCM. So here LCM of 15 and 30, we can write it as 30 directly. So here we have 15 and here we have 30. So this 1 has to be multiplied with 2. So this becomes 1 into 2. Then we have this plus sign. I hope you know the basic things. That's why I'm not teaching every detail here. After finding the LCM, what you have to do, you can just multiply with the number that you need. So here we have 15, here we have 30. So 15 twice is 30. So 2 multiplies this 1. Here we have 30, here we have 30. So this 1 will be multiplied with 1. 30, 1 times is 30 equals to 1 by v. Now here you can simplify. So this becomes 2 and this is plus 1 divided by 30 is equals to 1 divided by v. So if you add, 2 plus 1 will give you 3 divided by 30 is equals to 1 divided by v. Here you can cancel 3 and this 30 is 10 times. Now you'll get 1 by 10 is equals to 1 by v. Now this is not your answer. What we have to find out is v. So what we have here is 1 by v. So here again student make mistake. So here you have to do cross multiplication. So this v into 1 becomes v and this 10 into 1 becomes 10. So this is the value for v, but when you write the final answer, make sure that you write the unit. So the unit you can see is in centimeter. So image distance will also be in centimeter. So we have found out the first unknown, that is the position of the image or the image distance. So the image distance here comes out to be 10 centimeter. Now we will go to the second part. We will find out the height of the image here. Below, I don't have space, that's why I'm rubbing the board. So here we have obtained V is equals to 10 centimeter. Now we are going to find out HI. Now how can we find out HI? Now there are several formulas that we can use. M is equals to HI by HO is one formula from where we can calculate HI. But as I said, if there are two unknowns, then we cannot use that equation. We don't have the value for HI. We also don't have the value for M. Rather, we can calculate the value of M and we can put it here, but directly we don't have the value here. And the second formula that we can use is HI by HO is equals to minus V divided by U. Now, if you look at this formula, then HO is known, V we have calculated as 10 centimeter, U is given already. So here the only unknown is HI. So instead of finding M and putting it here, let's do it directly here. Because all the three terms are known, only HI is unknown. So let's use this formula here. So what we have is HI upon HO is minus V divided by U. As I said, whatever is unknown, you keep it single on one side, rest you take it on the other side and then put the value. So here we need HI, so we keep HI here. Minus V by U is kept as it is. Now we are taking this HO to the right hand side. Now this HO on the left hand side is in the denominator. If you cross multiply, then on the right hand side it will go to the numerator. So HO will be here. So we are ready to put the value now. So HI is equals to minus we have here. So V we have obtained it as 10 centimeter. U we have minus 30 centimeter. And HO we have plus 5 centimeter here. So you can simplify further before cancelling the terms. So HI, this minus and this minus becomes plus. So we have 10 centimeter divided by 30 centimeter into 5 centimeter. So you can cancel the terms now. Centimeter, centimeter gets cancelled. 1 0 here, 1 0 here gets cancelled. After that we cannot cancel any further. So you multiply in the numerator. 5 into 1 will give us 5 centimeter divided by 3. So you can keep your answer like this also, but it's better if you write it in decimal. So you have to divide 5 by 3. So it will give you 1 point. It will come 666. So you can round it off and you can write it down 1.67 centimeter. So height of the image, as you can see, is 1.6 centimeter. So we have found out the second unknown. Now the third thing is to find out the nature of the image. Now in order to find the nature of the image, you don't have to do any calculation. You can simply see the object image distance. You can see the height of the image. From there only you can write the nature. If you look at the image distance, it is plus 10 centimeter, which means the image is found behind the mirror. And here also, if you look at the image height, then it is plus, which means above the principal axis. So what kind of image do we get? And here you can see we have a convex mirror. So convex mirror always forms virtual and erect image. So here you don't have to do any calculation, simply write the nature of the image. So nature will be virtual and erect. And if you compare the size of the object and the size of the image, you will see that the object height is greater than the image height. That means image has been reduced or diminished. And since we are talking about a convex mirror, the image height will be always diminished. So here you can write virtual and erect, and also the image is diminished. So this will complete your answer. Don't leave anything. You have to answer the question in detail. So if you do this much, then you will get full marks here. But even if you don't do the calculation entirely, if you write the given terms properly, if you write the formula if you make some mistake here, but you write the answer with the unit, and for this you don't even need the calculation. So some basic concept is required. So with this you can get the full marks here. Let's solve some other questions as well. Okay, so let's solve the second question here. So the question says an object 4 cm in height is placed at 15 cm in front of a concave mirror of focal length 10 cm. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Calculate the height of the image. So here we are given a condition where we are using a concave mirror and certain parameters has been given, and we are asked to find some values here. So let's see what are the things that we have to find out and what are the terms that is given. So the first thing, you have to mark what kind of mirror is given. So write that here. So we are given, in this case, a concave mirror. So we have a concave mirror now. So let's see what are the terms given. So the first value here we can see is 4 cm. So an object 4 cm in height. So an object 4 cm in height, it simply means height of the object. So height of the object is given as 4 cm. Then where is the next value? Here. So it says placed at 15 cm in front of concave mirror. So what do we place in front of a mirror? We place the object. So this has to be the object distance, and the object distance is 15 cm. You can see I am leaving some gap in front of the value. That is to write the sign convention. Do not use the sign convention as you write the value. We will do it later, so it becomes easy for you. So leave some gap first, and then we'll use the sign convention afterwards. Then the next thing is given focal length 10 cm. So focal length small f is 10 cm here. Now what are the things that we have to find out? At what distance from the mirror should a screen be placed to obtain sharp image of the object? So what do we need to find out here? They are not saying find this directly. What they are saying is where we have to keep the screen so that the image of this object can be formed. So where is the image formed? So there we have to place the screen. So what are we supposed to find out? The image distance or position of the image, because we want the position or we want the image on the screen. So we are required to find out the image distance. So you have to read the question carefully and try to analyze, try to understand, then you can know what you have to find out exactly. And the second thing that you have to find out is calculate height of the image. So here you have to find out, next is height of the image. Remember here only two things has to be found out, image position and height of the image. Now let's use the sign convention before we go to the formula. So what kind of mirror do we have? Here concave mirror, and height of the object, as I said, whether it is a convex mirror or a concave mirror, object is placed above the principal axis, so it has to be positive. Now object distance, whether it is a concave or convex, we will place it in front of the mirror, that means towards the left of the pole. So towards the left of the pole, according to the rule, the sign has to be negative. And concave mirror, focal length is negative because it will be in front of the mirror. So again, it will be negative. So those who have not checked the video on sign convention, I am reminding you again, you please go through that video first. Understand sign conventions and then you can solve numericals. Don't jump into the numericals directly. Alright. So these are the things that is given, and these are the two things that we have to find out. Now how can we find out the first parameter, that is image distance? So we are given u and f and we have to find out v. So there is only one formula which relates these three, and that is our mirror formula. So you can write down, we know 1 by f is equals to 1 by v plus 1 by u. So don't put the value directly here. First rearrange the equation, we have to find out v. So let's bring u to the left hand side. So plus coming to the left hand side, it becomes minus. So we have 1 by v. So whatever term you have to find out, make it single. Only then it will be easy for calculating. Now you can put the value in this formula with the sign convention. So focal length f, small letter f here is -10. So -10 here. Then we have minus sign. Then u here is -15. So write -15 here, 1 by v. Now before you take the LCM, you have to see and simplify this equation further. So this can be written as -1 by 10. Minus and minus, this becomes plus 1 by 15. So this becomes 1 by v here. Now you have to take the LCM. So LCM of 10 and 15 will be 30 here. So minus sign is there, 1 is there. So 10, how many times is 30? 10, 3 times is 30. So this 1 needs to be multiplied with 3 here. Then we have this plus sign. We have 1 here and we have 15 here. So 15, how many times is 30? So 15, 2 times is 30. So I hope you know how to take the LCM and do the calculation. If you don't know how to do the LCM, then you have to learn LCM first. So here in the denominator we have 30. So -1 into 3 becomes -3. Then we have this plus 1 into 2 becomes 2. Now here again some students, they make mistake. They write -5. It's not -5. So there are two numbers, 3 and 2, with opposite sign. So whenever you have two digits with opposite sign, you have to take the difference, and the symbol or the sign will be of the greater number. So here the difference between 3 and 2 will be how much? It will be 1. 3 and 2 difference will be 1. Now what sign you have to use? Which number is greater, 3 or 2? We know 3 is greater than 2. So what is the sign of 3? It is negative. So here you will write negative. So always take the difference when you have two digits with different sign, and the sign to be used will be the sign of the greater number. For example, if you have 5 and -10. So this is +5, this is -10. So difference will be 5. So sign will be minus because 10 is greater than 5. Same thing, if you have 5 plus 10, you will take the difference. Difference will be 5. Now the sign will be plus because 10 is greater than 5. So this is how you have to do it. Alright, if that is clear, then on the right hand side we have 1 by v. Again, as I said, we are not finding 1 by v, we are finding v. So you just take the cross multiplication. So v will be directly, you can write down -30 centimeter. You may say -1 into v is -v, 30 into 1 is 30. So if you take the opposite, then you can simply write v is equals to minus of 30. Alright, so the image distance comes out to be -30 centimeter. So we have found out the first one. Now let's find the height of the image here. The image, again, which formula we can use? We can use hi by ho is equals to minus of v divided by u, because we have the height of the object given, v we have calculated, u we have here in the given. So we can simply find out hi. So hi will be minus v by u times ho. So hi, now use the value with proper sign convention. So we have obtained v as -30 centimeter. Then we have u as minus of 15 centimeter. It's given. And height of the object, it's given as +4 centimeter. Now you can do the calculation directly here also. This minus and this minus gets cancelled. Centimeter, centimeter gets cancelled. 15 one time, 15 two times is 30. So we have hi is equals to, we have this minus sign. So minus twice into 4 becomes 8 centimeter. So we were supposed to find out two things, v and hi. So we have found out v, which is -30 centimeter, and hi as -8 centimeter. Here you don't have to write the nature of the image. If you even have to write the nature of the image, then you can know or you can see from the given values or the obtained values that height of the image is negative, means below the principal axis, so image has to be real and inverted. And if you see the object height and the image height, then image height is greater than the object height, so it will be magnified image. Anyways, here you don't have to write the nature, so if you do this much, then you will get full marks. So this is question number 2. We're using a concave mirror. Okay, now let's discuss this third question. This third question is slightly different from the first two, and it needs better understanding of the concepts. Alright, so the question says the image formed by a spherical mirror is real, inverted, and is of magnification -2. If the image is at a distance of 30 cm from the mirror, where is the object placed? This is the first question. Find the focal length of the mirror. Also list two characteristics of the image formed if the object is moved 2 cm towards the mirror. Now this question needs understanding of the concepts. So please do watch the video on image formed by a concave mirror, because this case is related with a concave mirror. As you can see, the name of the mirror is not mentioned here. It is mentioned spherical mirror. So here it can be convex or concave. But with the given value, we can understand that this is a concave mirror. How? If you just look at the magnification, it is -2, which means the image has to be real. And only a concave mirror can form a real image. Convex mirror always forms virtual image. So this one is a concave mirror. So if you have understood that much, here you can write concave mirror. So how did we understand that this is a concave mirror? Simply looking at the value of magnification, which is -2. Now even if here this minus was not given, then you have to understand that this is a concave mirror. How will you understand? By simply reading this term, real inverted. So real and inverted image is formed by a concave mirror, and magnification for a real image will be negative. So if this is only written as 2, then you have to write m is equals to -2. But in this question, the sign for magnification is already given. So let's write the details now, whatever is given here. So here, magnification is given -2. And remember, magnification does not have any unit, so we will write only -2 here. Then it says image is at a distance of 30 cm. So what is given here? The distance of the image. So we have an image which is formed at a distance of 30 cm. Now the question is from where the object is placed. So that means you have to find the value of object distance. This is the first thing that you have to find out. Also you have to find the focal length. You have to find the focal length also. So focal length is also not given. Also this question says you have to list two characteristics. That means what kind of image will be formed if the object is moved 2 cm towards the mirror. So we will discuss this later. First let's find out the given unknown terms here. So magnification, the sign convention is already given. Now image distance. So concave mirror, it forms real and inverted image. That means image will be on the same side as the object. So the sign convention for image distance here will also be negative. So you have to see, you have to learn the sign conventions. Do watch that video on sign convention first. So these are the terms that is given. Now we were using mirror formula to find out the value of V in the first two questions. There two of the terms were given, U and F. But here, as you can see, in order to find U, we need V and F. But again, F is also unknown. So as I said, if two terms are unknown, then you cannot use that formula to do the calculation. For example, if you use the mirror formula, 1 by F is equals to 1 by V plus 1 by U. You are supposed to find out U. This is unknown. V is given, but again F is also unknown. So you cannot use this formula to find out U or F here. So you have to go for the alternative. So how can we find out U then? So what else is given that you have to see? Magnification is given. So do we have any relation between magnification, image distance and object distance? Yes, we do have. We know that magnification is the ratio of image distance to the object distance. So here this will be the formula that we can use, because V is given, M is given, you can simply find out U. So that's how you have to see which formula is suitable for the calculation. Alright, so let's do the calculation. So here you can write down, we know M equals to minus of V by U. We are supposed to find out U, so bring it to the left hand side, cross multiply. So U is equals to minus V divided by M here. So U is equals to minus V is nothing but minus 30 centimeter here. So minus 30 centimeter, and the value of M is minus 2. Remember, it does not have any unit. So minus and minus get cancelled, 2, and this becomes 15. So the value of U comes out to be minus 15 centimeter here. So this is the first term or first thing that we have to find out. So the object distance comes out to be minus 15 centimeter. Now the second thing that we have to find out is F. Now since we already have the value of U, we already have the value of V, we can use the mirror formula now to do the calculation for F. So for focal length, we will use the mirror formula. 1 by F is equals to 1 by V plus 1 by U. So 1 by F is equals to, with the sign you have to write, so V is minus 30 centimeter, so this becomes minus 30, this is plus, U is minus 15, so minus 15 here. Let's rearrange this equation further. So this becomes minus 1 by 30, minus into plus becomes minus, so minus 1 by 15 here. Now let's take the LCM and see the value for F. So the LCM here will be 30 and 15, LCM will be 30 itself. So minus is there, so 1, here we have 30, 31 is 30, so this will be multiplied by 1. Then we have a minus sign, this 1 is there. So 15, here we have 30, so 15 twice is 30. So we'll get this much. So 1 by F is equals to 30 in the denominator. In the numerator, minus 1 into 1 gives us minus 1. This minus is there, minus 1 into 2 will become minus 2. So 1 by F is equals to, this becomes minus 3 divided by 30. Divide this becomes 10. Take the cross multiplication or reciprocal also you can take. So F will be minus 10 and the unit will be centimeter. So the focal length of this mirror is minus 10 centimeter and its object distance is minus 15 centimeter. So we have finished this two. Now there is an additional question which says you have to list out any two characteristics of the image if object is moved towards the mirror by 2 centimeter. Now for that you have to understand the diagram here. If you have to do any calculation, you find the diagram, then you can write the nature. So here what we have a concave mirror. So this is the pole of the mirror, this is the focus of the mirror, and this is the center of curvature of the mirror. So what we have obtained is U is equals to minus 15 centimeter and focal length is 10 centimeter. That means this distance from pole to focus is our 10 centimeter. No need to write the minus sign so that it is towards the left. And initially we have an object somewhere here which is at a distance of 15 centimeter. Now the question says we have to move the object by, I think this is 10 centimeter, not 2 centimeter. If you move this object by 10 centimeter towards the mirror, you have to take this object towards the mirror by a distance of 10 centimeter. Let's shift this object from here to, let's say, here by a distance of how much? 10 centimeter. So remaining distance will be 5 centimeter. Now here you can see when we shift this object by a distance of 10 centimeter towards the mirror, our object comes in a position between the focus and the pole. So For a concave mirror, this is a special case, the last case that we have discussed in image formation by concave mirror. You can check that video. Whenever object is between focus and the pole, concave mirror forms a virtual image. That is the special case for concave mirror. It forms a virtual image and the image will be highly magnified. So you don't have to do the calculation. If you have understand this diagram, then your answer will be, the final answer, the image will be, so nature of image will be, it will be virtual, and virtual image is always erect, and the image formed will be magnified. So these are the two characteristics that you can write for the image when the object is shifted by 10 cm towards the mirror. So in order to answer this kind of questions, you need the understanding of the concepts. So please go through the video thoroughly and try to understand each and every case, because while doing the numericals you may need all these things. Alright, so I will be posting more videos on numericals. It will be a lengthy video, so I am stopping here, but I'll be posting more videos in the next part. Thank you, and do like, share and subscribe my channel, and please do suggest if you want numericals to be done from other sections or whatever you want for your preparation. Please do comment and also do give suggestion. Thank you.